Okay guys, welcome to 7.1. 7.1 is graphing inequalities. And an inequality is, well, this is inequality, and this is an inequality. There's an equality and inequality. So inequalities have less than or greater than or equal to, that kind of thing right there. So we want to define number one, half plane. You need to use your book to find out how you can find a half plane in your own words. And we'll get to some of this work here in a minute. So use your book to figure that out. Use your resources. Number one, I want to write a linear inequality in two variables to represent each solution problem situation. So number one, so look at the clues. Always look at the directions. So we're going to write a linear inequality. So it's going to have this. It's going to have two variables. We're going to represent that. So for example, the number one was Tanya. Tanya is baking zucchini muffins and pumpkin muffins for a school event. She needs at least 500 muffins. Okay, so if you said x plus y is greater than or less than 500. You're saying that it's going to be greater than because she needs at least 500, which means that this side has to be bigger than 500 or equal to 500. 500 or more. Okay? This side is 500 more, and it's got to be bigger or equal to 500. So that's the example, and it would be really good if you actually define your variables. So you could say x equals zucchini. I think I misspelled that. 2 C's, and then y could be muffins. All right, number two. Okay, we got Hero needs to buy new pens and pencils for school. Pencils cost $1 and pens cost $2.50. He's got $10 to spend. Okay, so one, I'm getting out a pen, see if this works. I'm going to use x equals pencils. And I'm going to say y equals pens. So he only has $10 to spend. He cannot spend more than $10, but he could spend $10. So he could buy, and the pencils are $1 and the pens are $2.50. So you could say, well, he could buy 1 times x. X is the number of pencils, and 1 is the price. And then he could buy $2.50 times y. That's the number of pens, and that would equal. Wouldn't really equal. It could be less than, or it could be equal to $10. So again, this side right here. This right here would have to be less than or equal to $10. Let's see, less. This side has to be less than $10. It cannot be more than $10. This pencils and pens worth of money cannot be, worth total cannot be more than $10. Okay. So the key of this lesson is understanding that some things could be less or equal to, or perhaps even greater. Let me delete some of the stuff here. All right, number 3. Patty makes decorative flower pots. It costs her $20 to purchase the materials for each pot. So each pot costs her $20 to make. Okay. So if she made 2 pots, they're decorative flowering pots, it cost her $40. If she made 3, it cost her $60. Okay, and she wants to charge $6 more. So she wants to make $6 profit. So if you think about this in this idea, whatever her cost is, she wants to add $6, okay? And that's what she's going to sell it for, okay? She doesn't want to charge $6 more. She wants to charge $6 per hour. So if she spent an hour decorating, she wants to charge $26. Think of it this way. Make a T-chart. Okay. So if she costs $20, and then the hours. So if she spends 1 hour, she's going to charge $26 because she wants to charge $6 per hour that she works on it. If she charges 2 hours, she spends 2 hours decorating it, then she's going to want to charge $32. Okay. So the cost plus, the cost is actually $20, so you can actually erase this part right here. Okay, line erasing. Okay, so we can erase this for 20. So she wants to charge $6 per hour. Okay. Now look at this carefully. She wants to charge $6 more. Okay. She wants to charge more than $6. Okay. So the least amount she wants to charge is $6. So this right here is what she's going to charge. Okay. So then here we'll say P is the price she's going to sell it for. So P is price. I'm going to write that P equals her price. And then H is for hours she spends. So the price has to be bigger. Okay? Her price, the price she's going to charge, she's going to figure out how much she paid for it, plus $6 per hour that she spent. This number has to be less than P altogether. Okay? It's a real brain twist on this one, okay? And there's probably other ways you could have written this. Number 4. Jose and Devon are working on a construction job together. Devon can put in 4 times as many hours per week as Jose. Together they must work at least 80 hours per week. Okay? So I'm going to say J for Jose and D for Devon. I'm going to call him Devon. So for sure the easy equation would be Jose plus Devon. Together they must work at least. So what do you guys think of this? This side right here, if you add up these two, the number of hours Jose puts and the number of hours that Devon works, together it could be 80 or bigger, because it's got to be at least. This is the key right here. This side right here, their hours together has to be bigger than or equal to 80. All right, next, but this might be a systems here because there's another equation here. Okay. Devon can put in 4 times as many hours as Jose. So I typically want to use a table chart, a T-table, because I don't really know how to make the equation. Put Jose here and Devon here. And I usually pick the one who can work the least, the smaller number. So it looks like Devon can put in 4 times as many, so he can put in more hours. So if, okay, If Jose can put in 1 hour, then Devon can put in 4 hours. If Jose puts 2 hours, then Devon could put 2 times 4, which would be 8. And then I want to throw in the variable. If Jose puts J amount of hours, then Devon can put J D, J times D. Oops, not J times D. J times 4. Okay? Or you would say D equals 4J. And here's your second equation. Devon can put in 4 times as much hours as Jose. So for this inequality, I think the focus is on this inequality right here, because the second is actually an equation. It equals. See, Devon puts in 4 times as many. He doesn't say at least 4 times, or it doesn't say 4 times more. It says he doesn't put exactly 4 times as many hours as Jose. So you have 2 equations. One's an inequality and one is an actual equation. Okay. So go ahead and try number 5. The Foxes are playing the Titans. The Titans have been scoring 28 or more. Here's your clue. Or more points per game in this season. Between 7-point touchdowns and 3-point field goals. So look for this. This might be your variables right here. Here's a variable number 1, 7-point touchdowns. And variable number 2, 3-point field goals. They need to score more than the Titans' lowest score. Okay? So think about this one and try to make your inequalities and make sure to define your variables. Pause it here and post some stuff on Schoology. Let me look at the next page for a minute. All right, next page. Jack has made his fundraising goal, which has less than the total that Cameron raised. Cameron raised $14 more than 5 times her goal. Okay, so you have to make your inequality here. And for these other ones, from 7 to 14, okay, let's look at zoom in on 7. All right, the line will be solid because the symbol is greater than or equal to, okay? So when you graph these, if there is an equal sign underneath the inequality, okay, and it has an equal sign, and it doesn't really look like an equal sign, it just looks like part of an equal sign, which is the bottom part, then it's solid. Then the graph is solid. The line is solid. Okay, so go ahead and do the rest of these. If it's not, does not have an equal sign, then the line of your graph will be dashed, which means it doesn't include the line. Okay, when you graph it, it means anything before the line or after the line, but not the line. Okay, this will be dashed. Okay, and because it doesn't have the equal sign, go ahead and do the rest of those. And last, we're only going to go to 18. For each inequality, use the test point to determine which half plane should be shaded. Okay, on this, what you want to do is you want to test out if 0, 0 fits in there. Okay, guys, for 15 through 18, the directions are for each inequality, test out 0, 0. So we're basically, if you use your Desmos, go ahead and graph these with Desmos, and you can actually find out if 0, 0 is in the shaded area, okay? But you can also do it without using Desmos. by plugging in, we're seeing that's the x and that's the y. We're going to plug in 0 for x and 0 for y and test it out. So this one would be 0 minus 30 is less than 9 times 0. Okay, and then continue the algebra. So 0 minus 30 is negative 30. Then you test. Okay, test this. Is negative 30 less than 0? Yes. So this one does work. So 0, 0 is in the shaded region. And go ahead and type this in your decimals to verify that it is in the shaded region. So go ahead and do that for 17 and 18. And that's all the homework for today. Okay. What I really want you to focus and understand are the inequalities when you graph them with dashed or solid, and what do they mean in word problems? What are the key words in word problems? Go ahead and post this on the show, on the tutorial of YouTube. I'm sorry, on the YouTube comment section. Okay, that's all. Have fun.